some weeds that were on the sidewalk. That was nice. That was nice. I literally yesterday when I was walking, I was thinking somebody must complain because like when you walk into people, like you don't fit because of the weeds. So either one will get into the weeds or get on into the street. But yeah, so it's cool that they cleaned it up a little bit. So that's nice. So today we're going to learn about something called promises and fetch. Fetch particularly is another mechanism that we have to send network requests. So basically, fetch and XML HTTP requests are interchangeable. We can use one or the other. Fetch is more modern. You can think of sort of fetch as the more modern like ES6 and XML HTTP requests the older way sort of ES5. And actually, let's look at when fetch was introduced. I think it was introduced in 2013. Fetch web API. So here, like the documentation, remember to always visit the documentation. The Fetch API provides an interface for fetching resources, like including across the network. It will seem familiar to anyone who has used XML HTTP requests, but the new API provides a more powerful and flexible feature set. Yeah, it even said it right here. And let's look at Fetch API. I don't remember when it came out, but it's not here. Maybe here. Okay, so the built-in XML HTTP request object, or since 2017, the new fetch. So, we used to do it with XML HTTP request. In 2017, we got the fetch method, the fetch API, that will allow us to still make network requests in a more flexible and easier way. And we're going to be learning about that. And what else do we have here? Oh, this is great. This is a good Wikipedia article because it shows an example with XML HTTP request. Maybe we could do this as well. It shows an example with XML HTTP request, and then it shows the same example with fetch. It's doing a lot of stuff that is not fetch related, like await in async. We're gonna get to see this soon. Maybe we can sort of translate the code that we have with XML HTTP request, sort of translate it to to the fetch API. So instead of using XML HTTP request, we use the fetch API. I really quickly wanted to review the exit ticket. I think also there are some exit tickets that we haven't reviewed, and I plan to do that not now, but I still have them in mind. I just wanted to check out the one today, the one that we did yesterday. I think you all did pretty well. So the first question, like what does Ajax stands for? 100% you got it, asynchronous, JavaScript, and XML. That was what it stands for. This one, why is Ajax useful? All of them are correct. Ajax will allow us to receive data from a server after the page has loaded, update a web page, send data to the server, or request data from a server. Those are sort of, requesting data, I guess we are implying here that you're not sending any extra information to the server, like on a GET request. When you're sending data to the server, we didn't get to see that example on XML HTTP request, which will be like a post request, creating a post request with XML HTTP request. That will be like sending data. Yeah, here all of them were correct. Here we have this piece of code that says basically our fetch images or whatever you called it yesterday. And this was asking what will happen when the function below is called. So imagine this function will be called once the user clicks on a button. And what is this? What is this going to log? Anyone who wants to give it a try? What are some of the components that this has, or that it doesn't have that we included yesterday? John? It doesn't have an XML.send. And what does that imply? Like, what is the consequences of that? What are the consequences of not having a send? Yes.
It will set up all the stuff it needs, pack up your bags, and get ready to go to school, then miss the bus.
Correct. That's a really good analogy. Yeah, it does all the setup, but it never goes out because the request was never sent. So here we'll see. Also, because it was never sent, and because it was never sent, and the ready state will never be done, we will never see this console log. Remember that there's 4 ready states. One, that the request was open. Wait, I already forgot the status codes. Let's refer back to. No, is it? Ajax. Here. Okay, yeah. One that the request was opened, so that gets fired once we have this line. Right? 2, that the headers were received, but for the headers to be received, or also means the request was sent, we will need to basically send the request, right? And we never call send. Therefore, we never get to status 2. We never go to status 3 because the request was never sent, and therefore we never get to status 4. Because again, the request was never sent in this example. Therefore, this function, the function that is on ready state change, this function will only run once. And it will run once when you do XML open, which state changes to 1. But that state 1 is not equal to the done state, which is 4. Therefore, we never see this console log. And here, I think most of you got it correct. It will not log anything because XML send is never called. Here, it will not log the got the data because the request was never sent. Therefore, we don't have the data. This was we had the status, the ready state here. So yeah, 0 means onset, client has been created, but open has not been called. 1 means open. 2, the headers were received, meaning the send was fired. 3, the downloading the data, so data is arriving. If we have, here we're not fetching big objects, we're not fetching large amounts of data. But if we were, we'll get multiple times the downloading state because it will not be made all at once. It will be made in chunks, and we'll see the downloading state more than one time. And in the for, and I think the one that we're most interested in, the operation is complete. Cool. Any questions or comments, thoughts about this? Okay, so how did it go with the lab? Well, I wanted to review that because I think there's one piece there that we need to understand before we move to fetch, and it's exploring more about what asynchronous means. So let me look at the lab. That was. The lab was to use the dog API to basically display an image of a dog, right? And once you click a button random, it will display a random dog. So okay, I'm gonna do this. I'm gonna do this real quick so that we all see. And if you have any doubts or questions, you can ask them. I'm gonna go to my folders. Unit 2. What we were working on yesterday was Ajax. And here I'm gonna clone. Actually, I guess I'm not gonna clone. I'm just gonna create a folder. Lab. In here I'm gonna create 2 files. Lab HTML. Lab.js. I'm going to open this in VS Code. I'm going to be moving sort of quickly through this, but if you have any questions, feel free to just raise your hand and we can address them. So here we need the HTML. I'm just going to copy this HTML from here. Oh, I guess I'm not. Head. Do I need anything here? Just title. And then the body. I'm going to have an empty image here where I'm going to put the image of the dog once I get it. And then I'm going to create a button. Let me give it an ID. Well, since we only have one, I'm not. Okay, this is what this looks like in the browser. Cool. So we have a broken image because, well, the source is set to an empty string. and we have our button. What we want to do is when we click this button to fetch a random dog picture. So for doing that, we will need to add an event listener to the button. That listener, that function that gets fired when the button is clicked, will make the network request. And we'll also need to, once we get a response from the network request, which is going to come in as JSON data, we want to use, in that JSON data, we're going to get the URL for the photo, and we just need to use that URL to set the image source. So let's do that. First, we know that if you're dealing with, well, let's think about that later. If we're dealing with adding stuff to the DOM, removing stuff from the DOM, we'll want to make sure that we are in the document that add event listener DOM content loaded. I'm gonna leave this here. That's oftentimes what we have at the top. It doesn't need to be at the top. But before, so to accomplish this task, I need to first make the network request. Right? The network request on its own doesn't need to do anything with the DOM. So I'm breaking down my problem as to, I need to make the network request. So when a click happens, what I want to do is fetch data. And then after I've done that, I want to fetch data here or fetch image URL. And after we do the fetch data, what we want is display the picture. So I'm going to call that display. Display the data or display the image. So here I'm going to, since I found that I could break down my problem into these two steps, I'm going to create a function for each one of those steps. One function will take care of handling the XML HTTP request, and the other one will be taking care of displaying the image. In fact, let's write those here. Const, let's do get dog or fetch dog image. What does this function need to work? I always like to think when I write a function and I'm writing the parameters here, I always think, what does this function need? What should I feed this function to work? At this point in time, this function doesn't really need anything to work. We just need to, or it doesn't need anything from outside to work for me to need to pass anything here. And then once we do that, we think about, okay, what would this function do? We know that it needs to fetch a dog image or make a network request. We could call this whatever you call, as long as you communicate sort of the intent of the function. Here I call it fetch dog image. Now, this function is to make an XML HTTP request. So for that, as we saw yesterday, we will create a XML XHR, as I like to call it, XML HTTP request. We create a new instance of the XML request class. Then we do xhr.on ready state change. Here we want to put a function. And this function, we need this function to be ES5. And we need this function to be ES5 because as you saw in your code yesterday, you were using the this keyword. You remember when you say like this, we were doing something like console log this, that response, right? It turns out that when we're talking about this in here, we're meaning XHR, the request itself. This is one of the reasons why Fetch came along, because this feels very uncomfortable, having to think about having to do ES5 and having to think about that the response is inside of the request object that is XHR. So, but hopefully this is going to help us demonstrate a point here. So we do that, and then we want to check if the ready state is done. And if so, we want to parse the response. So for now, let's just console log the response like that, like the way that we're doing it. So let's just leave that. Next, I need to open the XHR, setting up the method that I want to use and the URL where the request is going to go. Let me take the URL from here. Also, let me disable this thing. So we open with the request method that we want, and lastly we do send. Am I missing anything here? Dinesh? No, we're not parsing yet. So we're going to see that next, because I want to leave that a little bit more clear. So, okay, so we have this function that will make the request or fetch the dog image. That's the job of this function. It's not fully doing its job yet, or it's doing it, yeah, partially. It's not what we want yet. But we know that we want to fire this function when the user clicks the button, right? So for that, we need to add an event listener to the button. For adding that event listener, since we need to grab the element from the DOM, we better make sure that we are doing that inside of the DOM content loaded listener. So here I'm going to do let button equal grabbing it from the DOM with document that query selector. Since I only have one, I'm going to do it just by the tag name, button, and then I do button dot add event listener. I want to listen for the click event. And who's my listener or my function? My function or my listener is fetch dog image. So how does this feel so far? Cool, familiar? That's good. So now let's refresh this page. And let's see if when I click the button, we're actually making a net request. So I'm going to open the inspect. I'm going to go to the network tab. And if we hooked up everything correctly, and I click the button, we should see a request popping up here. We're not seeing that, which means, what does that mean? It's a 3-letter word. We have a bug, yes. We have a bug, and we have to find out where that is. So for some, I click this, I see that everything seems to be hooked up correctly, but somehow there is a disconnect. Somehow, maybe it could be, look, maybe I'm not attaching the event listener correctly, or maybe the disconnection is somewhere else. So let's look back at this. So how do you debug something like that? That you don't have an error. So there's basically no hints. The only hint that you have is that it doesn't work. One way will be, let's try to console log here, sort of to see if this JavaScript file is running at all. Yes?
I don't know if you connected the script tag in the...
So that's actually the problem. Yes, we haven't connected, I haven't linked my JavaScript with my HTML through a script tag. That's the problem that I'm having. And here, if we console log, this is a JS file. We see that I saved, we don't see anything happening. We should at least see this if we have our JavaScript correctly linked to our HTML. So as Douglas said, yes, I forgot the script tag in here. So let's do that here. Script, src, lab HTML, rel. Is it a rel property here? Text. Script. Rel. Yeah, I don't think we have a... It's just type, that's the one. Just good to include. Type, text, JavaScript. That's it. So hopefully now that we have our JavaScript linked, we go back here, refresh this. Okay, good thing that we see our JavaScript running. This is a JS file. Where am I? Yeah, here. So that is this console log running. And then here, so now if we click the button, something should be happening. Oops, so we got something, we got the console log. We could just verify if the net request is being made. by looking at it here. Let's refresh. We can see that every time I click, I get a new network request that is being made. Oh, also I wanted to show you this. If you see how status is 200, and even it seems like it's really quick, but there is another status here that says like pending. I want to show you if I was like in a slow 3G network, I think that status should be for longer. You see, it says pending for longer. So I'm sort of Chrome lets you mimic a slow network to see how your website will behave on a slow network. So here, like when I click it, you see that it's slow, it's still pending. So this is an operation. Network operations are stuff that takes time, and it could fail because if you're not connected to the internet, there's a ton of reasons why a network request will fail. One, you're not connected to the internet, or the server that you make a request to is not connected to the internet. It could be also that the request that you made is giving you a 404 because it couldn't find anything. That will also be a failure. Well, it depends on how you consider it. But anyway, so we're making the network request, and this is what we get back. What do we get back in here as the response, and that I'm also console logging here? What is this thing? A string. And in what format could we say that this is string? JSON. That's correct. So this is the data that we get back, and when we get data back in using XML HTTP requests, we get the raw data. You could think of, like, once we get into Fetch, you could think of XML HTTP requests like curl. Do you guys remember curl? The command that is in terminal that will let you make network requests. That gives you like raw data, and you have to do much more work to process that data, but you also get much more control as to how you get over the data. And so that will be like XML HTTP request. Like you have a lot of control over the data. On Fetch, Fetch will be more like, I think that might be a little bit of a stretch, but it will be sort of like Postman, where it's much more easier to make the network request, and you do a lot, you get a lot of stuff done for you. So okay, so here we get, this is the response that we get back. This is raw text. This is raw text that is in a nice format called JSON that will allow us to parse it and convert it into a JavaScript object. But at this point, this response is just raw text. What we want to do is interpret this raw text and make a JavaScript object, save that JavaScript object to a variable, so that then we can key into that object, so that we could do parse response that message, and then we can get the message. Or we could do parse response that status, and we can get the actual status. With the data that we have currently, we cannot do that because this is raw text. This is not an object. It's raw text in JSON format. So the good thing about JSON format is that we can parse it, we can interpret it to create an object. We do that by saying, also let me show you here that if I do type of this.response, go to the console. Oops, did I say? Oh, I still have it on a slow network. I get a string. So that is, the data comes in as raw text, a JavaScript string. But what we want is convert that raw text again into an object. So to do that, we have to parse the response. And we do that if we can do that. Let's create a variable here, parse response equal to, so to convert this raw text that is in JSON format to an actual object, we have a function called parse in the JSON all capital object, and this function is expecting a string that is in the JSON format. Good thing that we have a string in the JSON format on this.response. Now here, let's look at type. Type of parse response. I'm going to console log this, and here I'm going to console log the original type of this.response. So we're going to see the type of both the original response and then the type of the parse response. We'll refresh this, click the button, and we get that the type of the this.response is a string, the raw text, and once we parse it, that becomes an object. The good thing about objects is that then now we can key into them, loop, add more keys, remove keys, or properties. That's a better name. Anything that we could do with a JavaScript object. Fetch has its own way of doing like the parsing that we're gonna get to see. And once we see another, so we're gonna see sort of 3 ways to make network requests: XML HTTP request, fetch, and another one called Axios. Axios is the easiest to use and the one that we'll be using the most, therefore. And Axios, for instance, does this step for you. It parses the response for you. So when you access the response, you'll be already an object if it's coming in as a JSON formatted string. I know this is confusing, and I want to answer any questions about the parsing process. Yes, Art? Sure. Uh-huh. Yes, Malik?
The problem on yesterday is that I'm typing in this stuff and it was in all caps. Is there a reason it has to be all caps?
So that's a good question. If you misspell this done, this is a property a property in the this object, which in this case the this object is the XHR object. But the thing is, this property doesn't exist in that object. It has to be all capital, and we use all capital for constants. So something that will never change, we use all capital. For instance, math.pi. Math.pi is like pi is this fixed number, right? And we can do, if we go to the browser, math.pi. See, I have to put it capital. If I misspell any one of those, here is because it's auto-completing. But now we can see that it's going to give me undefined because. So yeah, we use capital to signify this is constants, it will never change. Mm-hmm. Questions? Comments? Okay, what if so let's get to finish today. So here I have basically completed this step. Fetch the data. I'm getting the data. I have my JSON object now. Okay, now let me get rid of this. and this. Now, I know that we're done if we're inside of this if statement, right? And now we want to do the second step, display the image. I could write logic here inside of this if statement that will append the image to the DOM. But that will make my if statement sort of bulky and also harder to understand if somebody else is reading it. I better have that logic in a separate function, properly named, and then here I just call the function. So right now I'm going to create another function. Maybe display image. Now I think, okay, what does this function need to work? What pieces of data does it need to work? What do you think? Joanne? Correct. It needs a value from the parse response, right? What value is that? It needs the URL of the image. Right? This display image needs a URL to display, to create an image and display it. Right? But we have a problem here, or an apparent problem, which is, oh, the URL is in the parse response. If we do, let's use console log here. Parse response. Here, this is now the data that we got back, but now parsed now in a JavaScript object. If we go back here, refresh, we click, now we get that this is the object. Before the data was raw. That's just for comparison's sake again. Let's do this. That response contains the data raw. This is the raw response, raw text. This is the parse response in an object. And here, now that we actually have a full-fledged JavaScript object made out of the data, we can key into it, and we see that there are two keys, one message and one status. The URL that we're interested in is in the in the message property. And if we check out this URL, we get our dog photo. So we know that our image URL will be in the message property, and somehow we need to pass that down to our display image function. So we know that here this will need a URL. I want to pass in a URL here. Right? So, and we know that the URL, we have it in parse response.message. So what I'm going to do here is, instead of console logging this, I'm going to call my function display image, and let's do this. Let URL or URL equal parse response.message. So now parse response is an object. We take the URL, we take whatever the value of the message property is, and we put it in a variable called URL. And then I give to my display URL, my display image, the URL that it needs to work. Here I created this URL variable, but I could also have done this. Instead of creating a URL variable, I could just pass in the value directly here. Sometimes it makes sense to create a variable if you think it's going to make your code more readable. Don't doubt to create the variable. Sometimes it's not necessary in this scenario, because we know that the parse response message will have a URL. Okay, so questions here so far, Michael? Oh, that's a good question. Like having a return here. We're gonna get to that next. That's correct. Yeah. Yeah, we're gonna get to that next. That's the point that we want to explore. Mm-hmm. So okay, so we have the URL. Let's console log here to verify that this function, the display image function, is being called. I'm gonna console log URL. Here, let me get back to that. And I'm just gonna call. Remember here, once the request is done, I want to call my function display image, and I want to pass in a URL. Here, I feel like something that I've seen some of you confused with is like this URL here has, or the name of this variable here has nothing to do with the name of this variable here. I could call this anything I want. I could call it like image source. Image source. Right? I could call this variable anything. What matters is that I pass in something to the display image. And then the display image will see that something that I passed in as the argument here, as the parameter that is expecting. It will see this image source as something called URL, as a variable called URL. Okay, let's see if we do console log URL here. That will be the image source. What do we get? Fresh. And we have this console log coming from lab.js line 22. Lab.js line 22, that seems like our correct console log. We can click on it and see if we get the dog. Cool. Okay, so now we're thinking about the display image. We have the data that we need to accomplish that step, which is having a image URL or an image source. Now, because in my HTML, I have already an image tag that is empty. I could just grab this image tag and set the source of this image tag to the URL that I got from the API. And I think that should display our dog photo. So for doing that, what we can do is, first I need to grab that image element from the DOM. I'm going to call it let img equal document query selector. Because I only have one, I'm just going to go img. And then I'm going to say img.source. I want to set the source property of the image. And I want to set it to be equal to the URL. The URL that we get, that we're getting from the API. I think this should do the trick. Let's try it. We got the dog, it's just too big. Let me set it. Let me set this here with, let's do 100 pixels, just so that we can see the image smaller. Yeah. And then again, another random dog, because I'm grabbing, after I click this button, and the request is made and the request succeeds, we call the display image function. The display image function is going to the DOM and grabbing the image element, whatever is there, and setting the source of that image to the new URL. And that's why we don't get, every time we get a different dog, we're not getting more images. We're just replacing every time. We're grabbing whatever image is in the DOM, and we're changing its source attribute to be the new image. There are other ways to do it. I think I saw some of you doing it like with replace child, where you have an image first, or with a pen. Yeah, I saw some of you doing like replace child, where you have an image already, and then you just create another one, and you say the parent of the image that replace child, the new image, replacing it by the all for the all. No, the other way around. Replacing the new image for the all. I also saw some of you doing append child and remove child, which is also fine. When you get the URL, you are doing document create element image. You set the URL and then do document dot body, or the parent of the image dot append child, and you are also removing the older image, which is also fine. I think the downside of this approach, I think, is the fact that at the beginning I'm displaying a broken image, which is not great. Displaying broken images is not the best approach. Right? I think I saw some of you, yeah, with the other approaches, the approach for appending child will be the best here, so that I don't have to display a broken image. I could just display no image at all, and then I create the first one, and then subsequently I grab the one that is there. Okay, questions, concerns, ideas to discuss? Malik.
Display a broken image because it has a fault, or will it still display a broken image? But
Say that again?
like it has a fault that's low, it's still like the original image. Like when you pay for it.
Yeah, this one?
Yeah. If it didn't have a fault, it still show that little icon.
If it didn't have a dog, you mean this dog?
Yeah.
So this is because I have this alt here. If I remove that, I get I guess I get that. I was still expecting the broken image icon. I don't know if this is cross-browser. Let's try it here. Well, we can see a difference between the browsers. Firefox is still taking the width of 100 pixels and putting it there, even though the image is not there. But Chrome completely doesn't show the image at all. Let's see once we have the alt. Oh, Firefox doesn't display the small little image broken there, which is interesting. Let's try Safari now. So you can see here the diversity of web browsers. This is what Safari will show you if your user is visiting your website over Safari and you have a broken image. I want to say it one more time without this okay, when you don't have any alt, Safari and Firefox will show you the space where the image will go. Chrome, nothing. So yeah. Okay, other ideas? Jonathan? Sure. So let's look at that option. Should we start with an image here or with nothing? With nothing? Yeah, that's still possible. So I'm not gonna start with an image here. We start with just the button. What we can do is, so now I don't have an image in the DOM. Now this query selector will fail, or will just give me null because, well, I don't have the image in the DOM. I had to create it first. So here, instead of document.query selector, what I want to change here will be document.create element. And here, I want to create an image element. So this will be on change. Once I created the image element, I set the source, just as if I had grabbed it from the DOM. That doesn't change. And lastly, I need to append it to something. I want to append it to the body, so I could do document.body .append child img. Let's call this like dog img. I changed my variable name to be dog img to be just a little bit more descriptive as to what kind of image we have here. And here we're gonna see something interesting happening. Let me refresh this. Now I click the button, and we get our image. Now, what happens if I click the button again? Another image comes out. A lot of images. Sometimes you may want to do this. Sometimes you may want to have this effect where you're just adding stuff to something that is already there. But in this case, we don't really want this, right? So how can we avoid adding new images? We need to replace the original or the first image that we had. How could we do that? So at this point, we have no image. Once I click, we have one image. And then once I click again, I want to remove this image and add the new one. Cameron?
When you're creating the image with an ID, then you can target that ID.
So that's a good idea. So Cameron's idea is create an image. Actually, I could do it without the ID, but Cameron's idea is create an image, add an ID to it, and then next time when you're trying to add a new image, target the one that was already there and just set the source of that image to the new URL. Say that again?
You can do it all and put it on the main image first.
Without having to have an image first? Okay.
Once you make it first.
Oh, but that's the thing. Like, we don't want to make it first. Like, we don't want to have an image here.
No, I'm asking the JS.
Oh, in the JS?
Then you, as long as it's made, so you can be appended first, and then you use breaks to find that.
So here, like now here, there's also a fork in the road where there's two approaches. One is we could do replace child to actually create a new image and then take down the old one, or get the old image and just change the source. Let's look at changing the source first. So here, here's what this one be interesting. So what I want to do is, first I want to attempt to get an image from the DOM. And if I don't get an image from the DOM, then I want to append it. But if I get an image from the DOM, meaning it's not the first time I clicked the button, I want to replace the source. So we're going to do this. Let ing equal document that query selector ing. I'm not going to do it with the idea. I'm just going to try to get an image from the DOM here. What will happen the first time? Here, I'm attempting to grab an image from the DOM. And now next thing I want to do is console log that. But we don't have an image in the DOM when we first start. What would that console log be? Once I click the button. Thumbs up if you say it's going to be an image that is going to be created. A thumbs down if you're going to see maybe undefined or null. So the two options are an image that would be magically created or undefined or null. Okay, thumbs down, null or undefined. Thumbs up, a new magically created image. Yes, Owen?
What did my console log on the HTML thing? Is that what you mean by the thumbs up?
Yes.
Okay.
Cool. So let's try it. Let's click, and we get null. So we get null because if we read the documentation for query selector, let me close this stuff. Firefox. If we read the documentation for query selector, let's do the W3 schools. Here I'm going to search for null here. So this is the documentation for query selector. It says technical details, the return value. Oh, but this is query selector all? No, query selector. It's going to return a node list object representing the first element that matches the specified CSS selector. This is why it's called query selector, because what you put inside the string is a CSS selector. It works just the same. If no matches are found, null is returned. Otherwise, it throws a syntax error if the specified selector is invalid. We haven't seen that. But the important part here is if no matches are found, null is returned. So what happens here is when we first start, we don't have any image in the DOM. Therefore, no matches are found. And query selector returns null. That null gets put onto image. So now we could use this to our advantage to check if no image was found. That means it's the first time the user is clicking. Therefore, we need to create the image. If an image was found, meaning it's not null, then that means it's not the first time the user is clicking the button, and we want to change the source of that. We want to change the source of the image that was already there. So let's do this. If image triple equal null, no image, I'm just going to do no image in DOM, first time clicking. First time clicking, what do I want to do if it's their first time clicking? Create an image, which we have already done here. So if the image is null, meaning we don't have an image, let's create a new image with create element, set the source of that image to the URL, and lastly, append that image to the DOM. Let's see what we currently have here. And I go here, refresh, and I'm going to click the first time. Okay, we got an image. I'm going to click the second time, and nothing is happening. Which is expected. This is what we expect, because we only want to, because now image is not null. Now, because we're running this function every time we click, therefore we get the query selector executes every time we click. But now we have an image. So therefore now this image here is no longer null. It's null only the first time. Michael? Yes, I could do a turner, yeah. Oh. Mm-hmm. Yes, that's one option. I just wanted to be a little bit more verbose with the if statement. Yeah, but that's a valid option. Okay, so we want to append the image. So you see how like this task sort of divided into two tasks now. One is like display the image if it's the first time, and the other one is display the image if it's not the first time clicking. And we get sort of that fork in the road there by this if statement. So we got one scenario covered, which is the first click. Now we need to cover the second click. In that case, again, as I was saying, the next time we click, because query selector now succeeded, now I found a match in the DOM, image is no longer null. In that case, I want to do that in the else. And I just need to do image source .src equal URL. That is the only thing that I need to have in my else. What I want is, if the image is not null, meaning we already have an image in the DOM, then just change the source to the URL. Let's go here, click on it again. Now we're running always, after the first click, we're always running into this else. This if statement will only run once, and it's the first time around. Sure, do you guys remember when Ben was showing us about the linked list, that you could just say if not node, instead of saying if node equals triple equal null? Here I could do the same. Instead of doing triple equal null, I could just say, this is a little bit, I think this is a little bit more expressive, where it says if not image, then we want to create an image. Otherwise, just change the source. We still get this to work. Anything we should revisit here or re-explain? Feel free. And you know, sometimes it's tough because this is only one option. There are other ways in which you could have done this as well. Like instead of changing the source image, I could also actually do the replace child. So, yes, Savita? Sure. Okay, let's look at that third option. So let's imagine we're not going to set the URL here. We're going to actually do the replace child in case the image is already there. Well, in this case, we still have our first case is still good, which is if there is no image, we want to create a new one. The next one will be, I'm just going to comment out this line. Okay, so this is a good exercise. So regardless of whether the image is there or not, we want to create a new image. Here we're only creating a new image if the image is not, if there is not one image already there. But if we want to use the replace child, what we want is to create a new image for every URL and just replace the entire image from the DOM. So I'm thinking about an example that we could talk about. So, like changing the source. Changing the source is just changing one property of the image that is already there, right? And if we change that property, which is I think the most important property in an image, then we end up having displaying a different image. But I think the image element is the same. We just change the property source. It's just like, imagine I'm the image and the source will be like my name, right? I could change my name and, well, now people will call me for a different name, right? But I'm still myself. Once we do replace child, it's as if I'm not changing a property of myself. I'm just another instructor is coming in here and is replacing me entirely. Not just my name, but like my entire self will be replaced. So that will be how we'll do it in that scenario. So let's look at that. Let's do it first, I think, the inefficient way, and then we can think about how we can optimize a little bit here. So I said, regardless of whether the image is, of whether we already have an image there, we want to create one. So if the image is there, yeah. Here, let's do let new image, new dog image equal document that create element is going to be an image, right? And I now want to set the source of this new image to new dog image dot source equal to URL. Now here, instead of appending, so note that here we have basically the same two first steps. We're creating an image and we're setting the source attribute. And these two images are different. Now here, what I want to do is actually replace the old image with the new one. So for doing that, first we need the parent, because we use replace child. The replace child method, we need to call in the parent. The parent, in this case, we know that is the body because we don't have anything else. But sometimes you will, if you have something nested that is inside a div that is maybe inside another div, you might not know. It's just the parent will not be the body, and you will need to grab the parent somehow. You could do query select or get element by ID to grab the parent. Another way to grab the parent, which is a very handy one, is every element, and this is tying back to like the linked list stuff. So you see, we have shared language between like linked list and the DOM, where you see that elements in the DOM are called nodes, just like in a linked list, a node element. And you see how in the linked list you have like the next property and it's pointing to the next. element in the linked list. In the DOM, we have, well, the DOM is a little bit more complex, but essentially it's just a really big linked list that has not only one path to the next one, it can have multiple paths. For instance, on the DOM, we have a property called children, or an element has a property called children, and that element are like pointing to all the children that the element have. Another property that we have that we're going to be using here is every node keeps a pointer, just like the next pointer on a linked list, to its parent, which is really handy. It's as if you can think of it as on the linked list, we have the next pointer that is pointing to the next element. Imagine if we have not only the next pointer, but also the previous pointer that I think some of you suggested before. It will point to the next element. And that will be called a double linked list. Right? Similarly, in the DOM, every element is a node, and every element keeps a pointer to its parent. And then in that way, we can access the parent of any element. So here, I said that because we need to have the parent so that we can do the replace child. We can only do the replace child on a parent. So for getting the parent of this image tag, the one that is already there, what we're going to be doing is image and accessing this property, parent node. Parent node. This parent node, in fact, let me show you here. Here. I'm going to get the image by doing let img equal document query selector img. Right. Oops. What am I missing here? So this. Oh, I think dog. Huh. I'm not sure why this one is not working, but let's just console log here then. Here, console log img.parent node. Even before we do this, I'm going to comment this out. So we get the random image. Oh, I have to have the console open. So this was the first time we didn't have any image. Therefore, image was falsy, was null. Null is falsy. We created an image. We set the URL. We set the source to the URL. We appended the image. Now I'm going to click again. And then I get this console log. Console log on line 30. Line 30 is console log image that parent node. Look at what I'm seeing. I'm seeing the body element. That is because the body element, in this case, is the parent of the image and the body. And I need the parent so that I can do replace child. I can only replace child on a parent. Right? So we know that this property, just sort of like the next pointer in the linked list, is pointing to the parent element. So here I just need to do, so first let's uncomment these lines. Actually, those lines could have been just uncommented. Here we created the new dog image. We set its source, and we have the parent. So now, once we have the parent of the alt image, which in this case is just image. Here, let me change this variable name to be like old image. Or not old, previous. Previous ing. Oh, I also want to change this here. So here, maybe this, the importance of variable names that can help clarify your code. So here, I have something called previous image. We know that the first time that we click, there is no image in the DOM. Therefore, image will be null. That is a falsie. Then we create a new one. Right? The next time we clicked, because on the step before, we had created an image called dog image, and that got put into the DOM. Now, previous image will be that dog image that we just appended on the third time we clicked. And then if previous image has something in it that is not null, meaning we have an actual DOM node in this variable, meaning we found an image already in the DOM, we run onto this else. Here we create a new dog image. We set the source attribute or the source property, and then now we're about to do the replace child. So again, for the replace child, we need the parent node. We'll do previous image, that parent node, that replace child. And here, replace child is a function that is expecting 2 arguments. The first argument, as VS Code is showing me here, is the new child, and the second argument is the old child. What's the new child that I want to append? New dog image. And the old one, previous image. So let me comment that out, just to revisit what we have here. On the first one, it works. Here, as I'm clicking, a new image, these 2 lines of code are running. A new image is being created, and the source of that image is being set. But I'm never displaying that image to the DOM. I'm never appending that to the DOM. We do that by replacing the child, replacing the previous image that we had there with the new image. And now, if I uncomment that, refresh here, click, we got that dog. We're replacing. Now we're fully doing the replace child. I wonder. I wonder if there is a performance difference. I think I see the blank screen for quite a bit. You see when I click, you can see the blank for quite some time. And I wonder if instead of doing it this way, like replace child, we do it the previous way, which is just setting the source of the old image. It will be faster. But I don't know, but we can try it out. But Savita, this will be the replace child strategy. Yes? So here is because of replace child. Let me show you again here. Replace child. VS Code is telling me replace child. The first argument must be the new child. The new child is the new dog image. So that's what I'm going to put here. New dog image. And then the second argument has to be the old child. The old child is the previous image, meaning the one that was in the DOM before, after the second click. And this will be the previous image. And you said, why the previous image instead of another one, but I don't remember which one. This one? Dog image? Right, okay, because this lines in here will only run if we don't have a previous image, meaning it's the first click. So this is like the first image. Let's change the name. First dog img. So the first dog img gets put into the DOM on the first click. Now on the second click, the first dog img becomes the previous image, right? And because now it's the previous image, the first dog image is now the previous image. Now therefore, previous image is no longer null, right? We actually have the first dog image there. Then we go into the else and we create a new image. We set the source of that image, of that new image, and then we just replace. We replace the previous image, which was at its time the first dog image, with the new dog image. Other questions? Yeah.
So what that's doing is not just simply overwriting the old one, it's actually taking a second to delete that whole image tag and then build a new image tag with that in.
Correct. So the example that I was saying earlier is when we were changing only the source attribute of an already existing image, is as if I change my name to, I don't know, any name. But if I come here, I'm still your instructor, right? I will still be this person. That is if I change one attribute of myself, I will change the name attribute of myself. But if we do the replace child, is I'm being janked out of this classroom, and you're getting a new instructor, completely new, different name, different body mass, everything. So, other questions, comments? Mike? Mm-hmm. Mm-hmm. Wait, you said let's put an image tag in the HTML, and then. Oh, I see what you're saying. Yeah, like. Mm-hmm. Yeah, that will be another approach. The approach Michael is suggesting is like when you refresh the page, just get an image immediately. In fact, we could do that if we just call this function here, fetch.image. So the fetch.image will get the image from the API, and after that, once the response has arrived, it calls the display image. And the display image will create the image and display it, append it to the DOM. In fact, so for that, we just need to call this function as soon as the DOM has loaded. And we could even, we will get an image by default already. So this is another motivation for like creating functions. You see, like, now I just need to call the function whenever I want this to happen. And here, because as soon as the DOM content has loaded, I want to get the image. And fetch.image is calling display image, which will create the image tag and display it. Here, I think this should still work as we expect. Mm-hmm. So, okay, one more question before we sort of transition into fetch. And I want to, like here what I want to do is like demonstrate or give you a better sense of what asynchronous means, because I think that's an important concept that we need to have clear. Other questions regarding this here so far? Yes, Owen?
Did you go to the top again? Okay. Don't you have the, is there a way to tell as soon as the page loads, just close the image?
Yeah, that's the one I was calling here. I was calling my function fetch starting. If you do that, then you'll get an image as soon as it reloads. Because, well, as soon as the DOM content is loaded, you're already fetching an image. Before, we were only fetching the image as soon as the user clicks the button. But we could also, because this is a function, we can call this function at any time. As soon as the user hovers, or as soon as the DOM content loads, even as soon as they start typing on an input box. That's how Google does its sort of prediction here. Hello. This is a box. This input box here has an event listener on it. That whenever I type a letter, is making an error request to Google server to ask for suggestions that match what I had already typed. Events in the DOM are really powerful. And this is all happening really fast. Okay, so let's look at what asynchronous means again. So these images are being fetched asynchronously. That means that actually, let's just look at an example. Let's look at this. Okay, I'm going to console log here, DOM loaded. And here, I want to console log fetch image started. Here. So I'm just adding some console logs here to demonstrate the point of asynchronous. Here, if I go to my console and I inspect, well, we already see some stuff going on. So here, I refresh the page and I see 3 console logs almost immediately. The first one is, this is a JS file. The second one is DOM content loaded. The third one is fetch an image started. You see, this is a JS file, it's the last line. Yet, we see it as the first one, as the first console log. So, this is the first sort of demonstration of asynchronous behavior. So here what happens is, it turns out that this function with the console log DOM content loaded is defined here, but it will not get executed until this event happens. This function that I'm highlighting here is defined here, but it will not execute until this event happens. And this event happens, this event doesn't happen immediately. This takes some time for the DOM to load. And we don't know how long it's going to take. If we're on a slow computer running Internet Explorer, it might take a few seconds to load, right? So that's why we use add event listener. We add this this listener function so that whenever this event happens, we fire this. And again, this event doesn't happen immediately. The other thing is, okay, so we do that. We see the DOM content loaded. So that's why we see this one. We see it first, right? Because code that is above here, the only code that is running here is when we first load the page is adding this event listener. We're adding the event listener, but the listener is not executing. We add the event listener to the document. That's the first thing that happens. And after we have added the event listener, we see this console log. These two here are function definitions. The functions will be defined, but they are not being called yet. So here, what's going on is the first thing that goes on is JavaScript adds the event listener to the document. It adds it. It doesn't execute it. It just sort of gives it. The next thing is it defines two functions, fetch dog image and display image. It defines them, does not execute them. And lastly, it executes console log. This is a JS file. All that we end up with being this is a JS file, console log first, because well, console log this is a JS file happens immediately. It happens. Another way that I was thinking about asynchronous and synchronous behavior, you could say like synchronous is like sequential. It will happen one after the other. So far the code that we've been writing is for the most part, we have been doing some asynchronous stuff that we haven't realized, but for the most part is synchronous code, right? You define a variable and then you console log it, and then you multiply that variable by 2. Those things will happen in that order. With asynchronous code or behavior, the order will be different depending on the asynchronous nature. Meaning, maybe you get an image like in here. The DOM loads. Trying to think of a good example. So think of a asynchronous. So think of synchronous code as sequential and that happens immediately. And asynchronous code as non-sequential, and we don't know when it happens. Well, we can't listen for when it's going to happen, but we don't know the point in time when it might happen. With synchronous code, we can predict when something will happen. With asynchronous code, we can just listen for when it happens, but we don't know when it's going to happen. No, this is correct. Asynchronous is non-sequential, non-immediately. So, like, actually, let's see if we could have. And most of the time we these two ways of writing code, they don't replace each other. Basically, we will most commonly be working with both of them. Examples of asynchronous operations are fetching resources from a server, or listening for an event. That's another example of asynchronous behavior. Some examples for synchronous is defining a variable and then console logging it. Defining a variable a equal to 3 and then console logging that variable. Calling function a where function a doesn't do anything asynchronous, and then calling function b where function b doesn't do anything asynchronous. Those will be examples of synchronous code. One will happen after the other. But with asynchronous code, the order might be different. It's not sequential. You will not. You have to be careful about the order in which stuff is happening. So, and this is an example of that. This app that we built is an example of that. So, first we saw that we are getting the synchronous behavior here, or what is happening synchronously, is we're adding the event listener. Remember, adding doesn't mean executing the listener. We're adding the event listener to the document. That's the first thing that happens. Immediately after that, synchronously after that, we define a variable called fetch.image. Immediately after we define that variable, we define another variable called displayImage, and these two variables are holding functions. Those functions are being defined, not executed. So immediately after the displayImage function is defined, then we console log this is a JS file. So because all this stuff above was definition stuff, it was not execution, the only execution line is this at the moment when we first load the page. That's why we see it first. And then what happens is right after, so JavaScript is like done here, right? JavaScript is technically like done. No more work to do. Right? At this point, JavaScript is done. It doesn't have any more work to do. But what happens is the DOM loads right after JavaScript is done. The DOM loads, and then when the DOM loads, it invokes the listener that was listening for that event. Now this function gets executed, and then we get the DOM loaded console log. But this was after like the main JavaScript was done. The DOM content loads, that event fires up this function, that we have here, and then that function just goes in and do its job. One of the things that we're doing is console login dump loaded. Okay, and then we see that. Now on this function, we see that this function is calling other functions. Right? This function is calling console log, it's calling fetch dog image, it's calling query selector to get the button, add event listener. So here we see the console log, and then immediately after that we're calling the fetch dog image. And these lines of code here, these two lines of code are not going to run until this piece of code is done, and until we finish with the fetch dog image. So fetch dog image will run, and that invokes this function. This function is on itself creating an XML HTTP request, defining a function to be on the onReady state change property of the XHR. Lastly is opening the request and sending the request. Right? Now, once this is done, once JavaScript finishes executing this, then these other lines will run. It continues where it sort of left off. Like here, you can think of it as like, this is a function, and we don't know how many lines this function has. It can be 1,000 lines. And JavaScript will have to execute those 1,000 lines first before it can move on to the next thing to do. The next thing to do is to grab the button from the DOM. Right? In this case, fetch dog image doesn't have 1,000 lines, but it's still doing some work. Therefore, we see fetch dog image. The first line is console log fetch image started, and then we see these two happening sequentially. Right? Immediately after the dump is loaded, here, let's do this. Console log button grabbed. We see first that the DOM loaded, then the fetching image started, and then the button was grabbed. That's because the fetching image started is part of the fetch dog image function. And then this is when this is going to get confusing. So here, if we look at the fetch dog image, we see the fetching image started. Note that I said started because I want to see other steps. I want to see when it's done, and I want to see, basically when it's done and when it's other states. So any questions that I can answer or clarifications that I can give right now about how JavaScript is executing this code. Okay, so far we see that the first line is this console log because, well, all this stuff was definition of stuff. We see the last line, then the DOM content loads. The DOM content load fires the listener in the function, right? Then we console log downloaded. The listener in the DOM content loaded is calling this function called fetch dog image. In the fetch dog image, so JavaScript goes to the fetch dog image and it starts executing. And executes the first line. We see the fetch image started, and then it's going to do all this other stuff. And lastly, after this line is done, JavaScript keeps executing where it left off, and then we see the console log button was grabbed after the fetch dog image has started. Okay, so now let's look at when the fetch dog image ends or is done. Let's do it. Let's do it. Well, let's do this. Actually, no. Let's do this. Console log fetching image done. So we know that when the this.ready state is triple equal this.done, we know that the request is done, right? Now let's see what we're gonna get. Refresh. We see this is a JS file, the DOM loaded, fetch an image started, button was grabbed, and then fetch an image was done. But note here how I said so what we're seeing here is button is grabbed before the fetching image is done. And note that in between fetching image started and fetch image done, we have the button was grabbed. So this is because grabbing or fetching the image, making a network request is an asynchronous operation that might take some time and it might fail if we have the wrong URL or the wrong method. But let's explain why this is happening. So you remember how I said when JavaScript gets here, it will execute this function, and once this function is done, it will keep going on to the next lines, right? And we will see the button was grabbed. And that's still true. JavaScript arrives to line 3, and it executes after the DOM content has loaded. It executes the doc image. The thing is, the fetch doc image, it finishes. Let's do here console log fetch doc image finish. So here we have, let's do this. Let's use the name of the function. Fetch image started. So here at the top we're doing the fetch image started, the fetch image function started, and at the bottom we're gonna say fetch dot image finish. Now here I decided to change that from fetching, so hopefully the language will help us see more clearly. So let's look at this. Refresh. Look at what we have. So the DOM is loaded, fetch dog image started, and fetch dog image finished. After that we have the button was grabbed, and lastly we have the image arrived, or the network request was done. So what's going on here is we're at this point, the DOM content loads, we see this console log. Now the fetch image, dog image executes, we see its first console log, fetch dog image started, all is good that so far. And then here we have something similar to what I was saying at the beginning, which is we're defining, we're not really executing. Here, just one more time. When we do document.add event listener DOM content loaded, and then we pass in this function, what we're saying, what JavaScript is doing is saying this function, and it's saying, hey, I'm gonna be listening for this event. Whenever I see this event, I'm gonna call this function, right? But this code here, we can see that this code here doesn't run until the DOM content has loaded. That's why we see that the first console log is actually the one last. Because at this point, the DOM hasn't loaded yet. JS is done. DOM. At this point, when JavaScript is reading this file, or when the JavaScript engine inside of Chrome is reading this file, it gets to this, it console logs, this is a JS file, JS is done, the DOM hasn't loaded yet, and the JavaScript, there is no more work to do. What we did was sort of leave this other JavaScript to be executed at a later point. We defined it and we left it to be executed at a later point in time. What is that point in time? Exactly, we don't know. We don't know how long it takes for the DOM to load. In a slower computer, it will take more than in a recent Mac computer, because you have more RAM. So we don't know when this is going to happen, but we sort of leave this function, and this is a callback, right? As we were seeing on the array methods, we pass in this callback to the add event listener, so that when this happens, then it calls back. That's why these functions are called callbacks. When that happens, call this or call me back. So again, here we don't know when this will happen. We know that eventually it will happen, but we don't know when exactly. So we cannot do this sequentially, right? Because we don't know when this will happen. Okay, but the good thing is that we know that it will happen, and at some point it does. We get the DOM content loaded. So this is that console log. After that, JavaScript will, in here, JavaScript is executing sequentially, right? First we see the console log, and then we see fetch dog image. But in here, JavaScript sees this function call, and it says, oh, I don't know what that is. I need to go and execute that function before I can move on. So JavaScript goes to this function, the fetch dog function, and it's executing because, well, we're using the parentheses, we're invoking the function. Then what does that function do? It console logs fetch dog image started. We see it here. It creates a new instance of the XML HTTP request. It adds a function to the onReadyStateChange property. It opens the request. It sends the request. And finally, it console logs fetch dog image. And that's why we see fetch dog image started and fetch dog image finished. Then the question is, why aren't we seeing in between fetching image done? The answer is the same reason why. The answer is the same as why we don't get to see DOM content loaded first, and we see it after the last line. So here, what we're doing, if we go line by line, similar to when we are adding an event listener to the document, right? We add that event listener for when one specific event happens, and in that case, we execute X function, right? And here is the same. We don't know when this request will finish. On a slow network, it might take a few seconds, right? We don't know the point in time when this will happen, but we can sort of listen for when it has happened, and we will listen by having this function here ready. This function is ready for any state changes to the request, and this function will be called whenever the request changes. But we don't know when the request will change. Here's like why we here again, like we are just defining this function. This function is not executing yet. That's a big point. Like the function, in fact, like we the developers, we don't execute per se this function. This function is being executed by the browser. The same way in which this function that's true too. This function here, we're not executing this function. We're just defining it. We're just saying, hey, here you have a function. Whenever the DOM content loads, execute it for me. It's the same idea. Here we're just giving the function to the browser, and the browser will see whenever this event happens, execute that function. Here we have the same thing. We are defining this function. We never note that we never say this. We never in our code say this on ready state change. We never invoke this function. That is because this is the browser's job. This is the browser's job to call the function whenever the request state changes. So in this case, this function is just put there for the browser to execute whenever the state of the request changes, right? And we don't know when that will happen. The only thing we can do is give the browser a function to call whenever it happens. In this case, it's an anonymous function. We have an if statement inside, checking for whether the ready state is done, and if so, we do other stuff. So in fact, the fetch doc image finish executing before this happens, before any of this code here happens. That's why we get fetch doc image started and then fetch doc image finish immediately. This here, all this stuff here is happening sequentially, synchronously. The thing that the asynchronous comes from sort of us leaving this function on the ready state change property. That then, so this code here, or the code inside of this function, we don't know when it's going to run. We don't know the point in time at which it's going to run. We know that it's going to run when the ready state changes, but we don't know when that is. And we don't need to know when that is. We just need to listen for whenever it is that it happens and then execute some code immediately after it happens. So just to step back a little bit, here the DOM loaded, we saw the DOM loaded. Then we start the execution of fetch doc image. The first line is console log fetch doc image started. Here we create a new instance. We define a function. We sort of give the XHR this function to call whenever the state changes. But that's it. We just give it, but we don't invoke it. We don't execute it. After that, we open the request. Lastly, we send the request, and then we console log fetch doc image because we're not executing this code inside. This function inside, we're not executing it. This will be executed by the JavaScript engine inside your browser. Then we see that we get the fetch doc image finishes, and then lastly after this has finished, the browser kept track of this function that we gave, right? The browser, we put this function in this property. Right? The browser will call this function whenever the request has finished. Or actually, whenever the request changes, its ready state. And we're interested in whenever it changes to done, because that's when we know that it's completely finished. Here, let's look at this. So this is when it's done, but we know here request state change. Let's look at this. So I added this other console log request state change because we saw that the onReady state change function gets called multiple times. Whenever the request changes from open to send to received, basically. Let's refresh this page. We get this. Holy cow. Let's look at, so we know that the DOM will load. After that, we call fetch dog image. That's what we see here. Note that the fetch dog image started. After that, we see a rec state change. This rec state change, which is inside of our function here, is happening because when we call open, the browser will call our function, opening the request. By opening the request, we're changing the state of the request. And therefore, we see the rec state change. After that, we get the fetch dog image finish. Note that we don't see another rec state change for the send. Right? Here you may be expecting two rec state change, one for the open and another one for the send. Right? The thing is that send here is the operation, the asynchronous operation, the one that is going to take some time when we actually send it. And we saw that status 3 stands for the headers were received, right? Meaning that this request was sent. But the headers were received is because, well, the request was sent and a response was gotten back with the headers. But so we will see this well, we see that once the browser has called the onReady state change function, after the request has arrived. Yes, Jonathan? Well, so yes, for handling user input, we're already seeing it, which is this, but we hadn't realized that this was running asynchronously, like adding an event listener to a click or to a text box. It's already asynchronous. Does not happen. We just leave the code there for the browser to execute at a later point, whenever the user clicks, for instance. Correct, yes. The DOM content load is an asynchronous operation as well, because we don't know when exactly, what point in time it will run. I guess that will depend on what you mean by specific situation, because non-specific situation. Right, yeah, but then what would be an if statement then? Would that be an if specific situation where you say if? Mm-hmm. Right. But in the if statement example, that would be synchronous code. That So I think you're starting to see that specific conditions are met. Yes, but I think my only problem with that will be that with an if statement I can express a specific condition that might still be synchronous. So we basically, okay, this is a good example. We do asynchronous operations when we are interacting with the outside world in our code. When we're getting when we are loading network requests, right? That is interacting with the outside world. Our code is interacting with the outside world. It's interacting with a computer that's somewhere, not even in America, maybe. Right? What's another example? We haven't gotten to see how we can load files or load content of files from our computer, from our hard drive onto our programs. But that will also be our code interacting with its outside world. It will be interacting with, we could think of this this JavaScript file here, right? This is its own little world in this file, right? And if we want to access stuff that is outside of this file, we'll need asynchronous operations because that's a boundary where stuff can happen. Stuff can take long or stuff can fail. And we don't want to have to wait until that thing fails or succeeds for doing other stores. Like in this case, for instance, we don't want to stop we could, but we don't want to stop to get the image before we grab the button. And that's what we're seeing here. You see how, where is the button was grabbed? You see, the button was grabbed before the request was finished. Imagine if we had to wait. Actually, I don't think this is a good example, but imagine if we had to, instead of grabbing the button, we're adding the button. We're adding the button to the DOM. Imagine if you had to wait until the request has completed to add the button to the DOM. They will not see, if you're in a slow network, they will not see the button until the request finishes. They will just see a blank page if we had the user wait. And that's what asynchronous codes allow us, not to have to wait until stuff happens. Oh, this is another example. You guys remember the command line Hangman game, right? You install a module called readline sync, right? Readline sync will allow you to wait until the user types a letter for doing the next thing. And to some of you, I said you could do it without readline sync. Because Node itself has a readline built into. But the thing is, that readline is asynchronous. Which means it will not wait until the user presses a letter. It will not wait until the user presses a letter. It will, similar to what we have here with the listening for the DOM content loaded, the readline sync will listen for when the user types a letter, and then it will call a function that is listening for that sort of event. The user can take an hour to press one letter. The user might not press a letter at all. So this is complex. This is not easy. This is not easy. But once we get comfortable with doing asynchronous operations, then this is when you actually can interact with the real world, like with the outside world of our programs and our computers. So one last thing that I wanted to point out here. So let's walk through this one more time to see how this is executing. So first we see the last line executing, right? Which is this one. This is our JS file. That's the first thing that we see logged in the console. After that, the DOM starts to load. We don't know when it's going to finish, but we have a listener function ready for whenever the DOM loads to be called, right? Then the DOM loads right after that, and we see the console log downloaded. After that, we call the fetch dog image. We invoke this function. This function, the first thing that it does is fetch dog image started. We see that happening here. The next thing that it does, it creates a XHR object, and it saves it to an XHR variable. After that, it adds a function to the onReady state change property of the XHR, and it moves on. It opens the request. Opening the request causes the state of the request to be changed. Therefore, we see our first. So open here internally. Open will call the onReady state change, and that's why we see right after the fetch image started. The next thing that we see is rec state change, the request state change. That's because open internally will change the request state. Therefore, we see this console log. We don't fall yet here because, well, the ready state is not done yet. Right after that, the XHR is sent, the request is sent, and we don't see any console logs for that in here. What we do see after that is console log fetch image finished, and that is this one. And this is then our function call fetch dog image is done. The function is done. The good thing that this function did was to leave a function here, leave this function on ready state change. It leaves it there so that when the browser is processing the request, it can be called, right? So again, at this point, the fetch image is finished. The fetch image function is done. And then JavaScript comes back here, and it keeps executing the let button and the console log button grab. That's what we see here. Right after the fetch dog is finished, we get the button grab. Right after this function is done, JavaScript keeps executing under whatever is after that. Then like here is after this. Here console log DOM content loaded listener is done. Missing argument. At this point, on the last line of our listener, the DOM content loader listener is done. This function will be done. Here, you can see that happening. So right after the fetch image dog has finished, but note that the fetch image dog finished executing, but we don't have a response yet. That's because getting the response takes some time. Doesn't happen synchronously. That operation doesn't happen sequentially. We sort of need to give the browser the browser this function that we save onto ready state chains for the browser to call, for the browser or the JavaScript engine to call whenever the state of the request changes. Note, so that function finishes. When this function finishes, we don't have a response yet. The function is done. It executed everything that it had to execute. And then we grab the button, that's this part here. Then we add an event listener to onClick for the button. And after that, the DOM content loaded listener is done. So that means this function completely finished executing. But because we left some stuff to be executed later by the browser when the request state changes, then whenever the browser sees that the request arrived, that we have the entire request, is going to change the state of the request, and therefore calling this function. And we say the request state changed 3 times after the DOM content loaded listener was done. And one of these, the last one of these 3 times is when the request has actually finished, has arrived with a response back to us. But we can see that like this console log, like this order of these console logs might not be what we expected initially, right? We see that the last thing that happens is actually getting the image. So we refresh this page and there's a ton of stuff happening. The DOM is loaded. We add in an event listener to a button. What else are we doing? We are setting up and sending the request. So here you could say like, another thing we could say here is like, this is, I don't know if this will provide more clarity, but console log request about to be sent. We get the request state change. This was when we opened the request, this line here. Then we see console log, the request is about to be sent. We can see that right after request is about to be sent, we see fetch doc finish. So somewhere in between these 2 console logs, we sent the request. That's an operation that might take some time and it may fail. In fact, actually, let's do it slow. I think that will be interesting. If we do network, let's do slow 3G. I think this will probably hopefully bring it home. You see it hanging there? So here, JavaScript is done. But then the request arrives. I wish I could make it slower. Then the request arrived. And then the browser is calling the onReady state change. And whenever the request state is 4, we get the fetch image is done. Like we actually have a response. Like here. Or we could change this to response arrived. Request state is done. So here, let's make it really slow. 1 kilobyte per second. Let's see if this works. Slow, slug. Here. So at this point, JavaScript is done. But at some point, the request fully arrives. This is because I'm simulating a really slow network. I'm simulating a really slow network, and here JavaScript is, the DOM content is loaded, the DOM content listener is done, but after all that time happens, because we left that function to be executed later when the state of the request changes, later on, well, the browser, the network request arrived, the browser updates the state of the request, and finally, we get that the request state changed 3 times, and the last time we actually got the response arrived, the request state is done. You can also see it taking some time here. Status pending. It's taking, so this request is 265 bytes, I guess. And we're transferring 1 kilobyte a second. So this will, oh, we can see here, it took 5 seconds to get the image. But I can sense the heaviness of the air. This is a lot. This is a lot. So let's take a 10-minute break. And after that, we just get you introduced to Fetch. Fetch, we're still going to keep this conversation. This is sort of like linked list. Like, this is not something you'll get out on the first try. We're just keeping this conversation as we move along. So, yeah. Go stretch, get some water. Sure.
Our JavaScript that we write is synchronous, and then any request that we get network.
Yes. Mm-hmm.
So anything that depends on any outside source.
Correct. Yeah, that's the best way to think about it. Like, yeah. So Joy. Oh.
you hit that little dip.
Okay, so what we're going to do is learn a little bit about fetch, and in fact, I'm just gonna. I think it will be good to just translate this network request that we were making with XML HTTP request, translate it to fetch to see how that works. And also here, so note that we were handling those asynchronous operations by leaving functions that the browser will execute whenever an event happens, whenever the content loaded, the DOM content loaded, or whenever the request status changed, right? We were leaving those functions to be executed at a later point, where we don't necessarily know what that point in time is. So first, let's look at how we would handle that with fetch. Actually, I'm gonna save this. I'm gonna make a copy. Wait. I'm gonna make a copy. No, of this file. So that we have sort of both, and then I can share these copies with you. I'm gonna do lab fetch. So one is like lab fetch, where we're going to do the example with fetch, and the other one will remain XML HTTP request. And I'm just going to change one of them. So here, I think I'm still going to leave this consoleize. The only thing that we're going to change is this function, the fetch.image. Instead of using XML HTTP request, we will be using the fetch function, the fetch method, also known as the fetch API. But note here, like also, the fetch API is different from the random dog API. The random dog API is a server where we can get random images from. The fetch API is just a new function that was added to JavaScript in 2017 to make network requests more easily. So, in fact, I guess let me start writing it here. So, fetch. To use fetch is more straightforward. I just do fetch, and fetch is a function. And this is a function that is globally available, so we don't have to do anything that fetch or import anything. Fetch is globally available in the browser, in the environment of the browser. Here we say, VS Code is telling me what is the request information. And this request information will be a URL. So here I'm going to paste this URL that we have here. Paste it there. So note how on fetch we don't need to create an instance of a class or anything like that. We just do fetch, and we pass in the URL to the fetch function, and then here what we need to do next is listen for when the request arrives, similarly to what we did here. We listen to when the request arrives by having this function here that the browser will call whenever the response arrives, right? With fetch, we have some methods that we can call on the fetch. Oh, so actually, wait. Let's do this. Let's call it let result equal fetch. Let's do this. Let's console log result. And I'm going to comment out this code. That is the one that is going to be replaced. So my fetch dog image currently has only fetch. We're calling fetch with the URL, and we save whatever that gives us back as result. So here, let's go to the browser. Let's refresh the page. Oh, I still have the wrong link here, source, lab, fetch. So let me just copy those, leave one, the regular one, and comment it out. But now I have the new one, the lab fetch, which I'm just where I'm converting this request to a fetch request. Refresh. Now we see that we're not getting the image. Something seems to be broken. But the question is the network request still being fired? Maybe the network request is being fired, but we're not getting the response. Because, well, when we do fetch, we process the response a little bit differently. Yes? Yes, I created a new file called lab fetch where I'm going to be making the edits. And then I'm going to share these files with you so that you have, the HTML is the same, doesn't change, but you'll have the two files, one with XML HTTP request and the other one with fetch. So here we see that we're clicking, nothing seems to happen, but I want to see if the network request is going out, if it's being fired. I'm going to open the network tab and I click the button. And we see that the network request is being fired because we see it popping up here. We can inspect it. We see that we got the response. Everything seems fine here. But what we are doing, or what we're not doing yet, is processing the response that we got from this network request, now using fetch. Also, so one thing that we need to do is figure out how to process the response. And let's look at what this console log is giving us. Let's go to console, refresh. So we see some of the other stuff that we had before, the DOM loaded, the fetch DOM started. Then we see promise coming from lab fetch line 16. So this is that console log. So I should leave this one, the fetch dog image finish. Let's refresh this. So we get the fetch dog image started. Then after that, we see this console log result. In this case, it's something called a promise. We haven't seen what that is. This is the first time we see a promise. And then after that, we have fetch dog image finish. The button was grabbed. The DOM content listener is done. So the new thing here is this thing called promise. And don't worry if you don't get it first. I didn't get it at once. But promises, you see how we talk about, we use objects in JavaScript because we want to model the real world, right? This is another instance of that. So, you know how when we do a car class that we want to represent a car with, right? That might have properties like number of seats, color, make, and model, right? So you can say that, yes, we're representing the real world into a programming language, into a virtual environment, right? And here, a promise is still the same thing. We are representing a promise. And can somebody give me a promise of in the real world?
Promise of not
I couldn't. Well, does she? Sometimes she fulfills that promise, and sometimes she doesn't. I couldn't listen. I couldn't hear the promise completely, but that's one promise. Another example. You promise that you will be there at a certain time, right? And then sometimes you fulfill that promise, and sometimes you don't, right? So this promise is the exact same thing. It's how we represent a promise in a computer. which is, yeah, I don't know, I think it's kind of cool that we are able to represent a promise. So this is a promise, so this is like fetch promising us that it will get a resource, that it will get this data from this URL. Fetch is promising us, or yeah, fetch, the browser or JavaScript is promising to us and the rest of our code that it will try to fetch an image. Sometimes that request, that promise will be fulfilled. Sometimes it will not. But note here that it says pending, right? So that means that this promise is pending. Is like when you promise something, but you haven't neither fulfilled the promise nor rejected the promise, or what's the opposite of not fulfilling? Anyway, that. So this promise is pending, right? Now we need to sort of, we kind of need to listen for when the promise is fulfilled, for when fetch comes back with our response. To do that, we can, there's a few ways in which we could do. So let's do this. We know that fetch, that's another thing. Fetch will always return a promise. So I'm going to call this promise. Nothing has changed here. We just change the name to promise. No, let's do a better name. Fetch request. Change the name to a fetch request promise. So this is a promise that fetch is making. That is going to go to this API and retrieve the data from it. Now we need to listen to we can think of listen to when that request has been fulfilled. And we do that by saying fetch rec promise that then. This is when the promise has been fulfilled, then do what I'm about to do here. Then execute this function. See the function that I'm writing here? I'm saying when the promise is fulfilled, then invoke this function. Invoke this function. I'm going to do console log promise fulfill. Fulfill. I don't know how to spell it. So here I'm going to console log promise fulfill when the promise is fulfilled. I could also listen for when the promise is rejected or when it's not fulfilled. Let's do this. Refresh this in the browser, and we got sort of the same that we saw with the XML HTTP request. We see here that the fetch dog image started, then we console log the promise that we got. The promise state is pending. We don't know if it has rejected or was fulfilled at this point. Then the fetch dog image finished. Then the button was grabbed. And lastly, the DOM content was loaded. The DOM content loaded listener was done. The last thing that we see is that the promise was fulfilled. That is because here, we're sort of leaving this function here. This function is not being executed until the promise has been fulfilled. And we know that with XML HTTP request, and that's still true here, we saw that fetching a request, fetching a resource from the network or from a server, that takes time. We don't know whether it's going to succeed or fail, and we don't know how long it was going to take. But similarly here, we did that then, we can have a function execute whenever the promise is fulfilled. Whenever, and the promise is fulfilled if we get a response back. And this is it for now. Once we come back from lunch, we'll continue on the then and seeing more. Any questions before we go to lunch? So here the that then is a function we invoke in the promise, and we pass to the that then function. Note that we're passing in another function. This function will be invoked once the promise is fulfilled. That is, once the request has finished. The promise of fetching a resource was fulfilled, then we execute this function. Cool. Let's go back for lunch.
It's really annoying. So I did this is from yesterday's lab.
Uh-huh.
So I did the regular request, I got the response.
Cool.
So I was trying to make the second selected, make it like dynamics.
Mm-hmm.
So if you chose one and if it had a sublist, then I guess
Got
would get
it.
updated.
Uh-huh.
So I was trying to do that, but the problem is, to do that, I don't want to make another request, because that'll be a lot of requests for
Uh-huh.
every change. So now I was trying to store it in like a global variable.
I see.
And I created two objects, so the regular data object and the next one is the Boolean object for that. Meaning
What
if
is
it
the
has a
Boolean?
false, true or false, meaning if it has a
Oh, I see.
subread or not.
Uh-huh.
So I did that, but then when I try to call it, like I call it at the bottom, like everything's done,
Uh-huh.
and I have my three things.
You're getting an
So I
undefined
call
or
it-
empty.
Yeah, but it's in there.
Oh, that's the thing, yeah. This is asynchronous behavior that we're talking about here. And it shows you, Chrome shows you empty, and then when you click, it shows you the actual value.
Right.
But that's because Chrome is just nice, and it says, oh, you ask for this information. When you asked me to console log, I didn't have it, but now I have it. I'm going to show it to you.
Oh, that's why.
Yeah. If you try a...
But I also put like a second, like event listener, another one,
Uh-huh.
called change.
You could also try... Have you explored the debugger?
No, I didn't look at that. But I
that's
do have
gonna
another
be-
event listener change. This happens after everything's done.
Uh-huh.
So, like when you change it, it's supposed to change. But you get like type error.
Blue
I
TP
mean,
is
undefined,
undefined.
what you said.
Uh-huh.
Async behavior, but this should have all been loaded. Like once it loads, the object should be created.
Also, so when are you fetching the subreads? When you select a breed, right?